Welcome to the class of Edunguru students. I am Sandeep Jain. In this module, we will begin with a very important chapter of mathematics, that is differential equation. Well, before starting differential equation, let us have a background. You must have studied radioactive decay in your chemistry classes. When you discuss radioactive decay, you say that dy dx, or the rate of change of a certain quantity, is equal to minus of kx. This is called radioactive decay. Or dy dt is equal to minus k times t. So students, some phenomenon occur in nature and they are discussed starting with a differential equation. So you can also observe that the simple harmonic motion in physics class starts with a differential equation, d2y dx2 is equal to minus omega square x. So there are many phenomena in nature, the rise in population or the exponential decay or the simple harmonic motion in physics, which start with a differential equation. So the first question which comes to mind is, how exactly do you define differential equation? After discussing that what is the meaning of a differential equation, we'll go to the order and degree of a differential equation. So this is the section, or rather this is the discussion point of this module. What is a differential equation? What is its order? And how do you define the degree of the differential equation? So I'll ask you students, start with you. Any one of you have any idea what do you mean by a differential equation? Yes, anyone?
Sir, an equation containing at least one derivative term is called as differential equation.
Okay, so the exact definition of differential equation, students, will go like this. A differential equation is an equation which contains independent variable x. Independent variable is mostly denoted by x, but the notations are not so important. Sometimes the independent variable may be x, may be t, but most of the times we'll come across questions in which the independent variable will be x. Some functions of x, you can have log of x, sine of x, cos of 2x, any quantity which depends on x, plus you must have dependent variable usually denoted by y. So dependent variable y, functions of y, and at least one derivative term. Remember students, it's only when you have the derivative term in the equation that your equation will qualify for a differential equation. Otherwise it's a normal equation, you introduce a derivative term and you get a differential equation. So the definition should be clear. Any equation which contains independent variable x, functions of x, dependent variable y, functions of y, and at least one derivative term of y with respect to x or x with respect to y will be a differential equation for us. We'll denote it by the short notation DE. So DE from now on for this chapter will be differential equations for us. Now students, after defining the differential equation, we'll take some examples so that you have an idea. Y dy dx is equal to x plus y. Y dy dx equal to x plus y is a simple differential equation. You can have d2y dx2 minus 5x dy dx equal to x square. This is also a differential equation. Remember, for an equation to qualify for a differential equation, you should have at least one derivative term. That's all. A normal equation containing at least one derivative term will be a differential equation for us. Take one more. Square root of 1 plus dy dx is equal to d2y dx2 whole to the power 1 by 3. Square root of 1 plus dy dx equal to cube root of double derivative of x. So all these three will be differential equations for us. Now, how do you classify these differential equations? By classification, I mean looking at a particular differential equation and the derivatives or the order of derivatives which that equation possesses, we classify differential equations according to their order and their degree. The differential equations, they become very complicated as the order and the degree of their increases. Particularly the solution part to the differential equation becomes tough. Later on we will see, students, that the solution to the differential equation as far as our syllabus is concerned will be restricted to those of first order, and in fact for most of the times it will be degree 1. So order 1 and degree 1 will be the differential equation which we'll be dealing with in this chapter. Now, how do you define the order? First and foremost, students, the order of a differential equation is a natural number. Remember, order cannot be a fraction, order cannot be a negative number, order of a differential equation is a natural number. So suppose you have a differential equation in which there is a d2y dx2 term, then we say that the order of the differential equation is 2. So just the value of the highest order derivative term occurring in that equation will be the order of the differential equation. So we define it as, it is the value of the highest order derivative term occurring in the differential equation. And remember, it will always be a natural number. For example, suppose you have d2y dx2 minus 5x dy dx is equal to x square. Suppose this is the differential equation you've taken, then the order of this differential equation, students, will be 2, because d2y dx2 is the highest order derivative occurring in the equation and the order of this derivative is 2. Do not look at the remaining part, the lower order derivatives, the radical signs, nothing. Just observe the highest order derivative occurring in the equation and the value of the derivative order is the order of the differential equation. Suppose you have square root of 1 plus dy dx equal to d2y dx2 whole to the power 1 by 3. Again, you don't have to look at radical sign, you just observe the derivative terms. You have two derivative terms, dy dx and d2y dx2. So we say that the order of this differential equation is also 2. So order of this differential equation is 2. Similarly, order of the second differential equation is also 2. If you want to take an example of order of a differential equation, or a differential equation rather, whose order is 3, you can say d3y dx3 plus ky is equal to y d2y dx2. So such a differential equation will have order 3. So order is very easy to read. You don't have to do any manipulation, students. Just look at the differential equation, find out, or rather check all the derivatives occurring. The highest order derivative, the value of that order will be the order of the differential equation. Coming to the second point is the degree of the differential equation. As I told you, students, in our syllabus we need to solve only differential equations which are of order 1 and most of the times which are of degree 1. So order 1 and degree 1 are the differential equations which we will be looking at most of the times, and we will be learning how to solve those differential equations. Before moving ahead, we will define degree of a differential equation. What do you mean by degree? This concept is a little complicated, or rather more difficult to understand than the order of the differential equation. What is the concept? It is the highest power of the highest order derivative occurring in the equation. Remember, students, whenever I say equation from now on, it will be a differential equation. So when all derivative terms are made free of radical signs. Radical signs here will mean square roots, cube roots, and so on. So the degree of a differential equation, students, is the highest power of the highest order derivative occurring in the equation when all derivative terms, remember, it's not the highest order derivative term which is to be made free of radical sign, it is all the derivative terms are made free of radical signs. That means before you read the degree of a differential equation, student, you must make sure that there are no radical signs over any of the derivative terms occurring in that particular equation. Suppose you have a differential equation dy dx is equal to, let's say, x plus y. Dy dx equal to x plus y is a differential equation of order 1 because dy dx is the highest order derivative occurring, so order is 1 and degree 1. Why degree 1? Because dy dx is the highest order derivative occurring and it is occurring with a power 1. It is occurring only once and it is occurring with a power 1. So order 1, degree 1. The simplest differential equation you can have, students, is that of order 1 and degree 1. Take one more. Suppose you have square root of 1 plus dy dx is equal to cube root of d2y dx2. Now you can see that the order of this differential equation, students, is 2. But what happens to the degree? This stage, or rather at this stage, we cannot tell what is the degree of the differential equation. For that, you will have to remove the radical signs from both the derivative terms occurring in the equation. So what I do is, I have a square root on the left hand side, I have a cube root on the right hand side, so I raise both sides to power 6. To simultaneously remove the cube root and the square root, students, I need to raise both sides of the equation to power 6. So raise both sides to 6 and I'll have 1 plus dy dx cube, square root raised to 6, students, will make it cube, and on the right hand side I'll have d2y dx2 power 1 by 3 raised to 6 will be square. So here I have all the radical signs are removed. 1 plus dy dx whole cube is equal to d2y dx2 whole square. The highest order derivative term is d2y dx2. It's occurring only once and the power is 2. So I say degree of this differential equation is 2. Order is 2, degree is 2. So the given differential equation has order 2, degree 2. Remember, students, the radical sign has to be removed only from the derivative term. Suppose my differential equation is dy dx equal to square root of x plus y, then I will not square this equation and say that the degree is 2. The radical sign dy dx, or rather the derivative term dy dx, has the power 1, so we say order 1, degree 1. We do not remove the square root which is over x plus y. So degree is to be read when all the derivative terms are made free of radical signs. Now, students, after discussing the definition of order and degree of a differential equation, I'll take up some examples to illustrate, or rather, how do you find out what is the order and degree of a differential equation. Remember, students, the first step you must be thorough with is to tell the degree and the order of a differential equation when it is given to you. So I start with my first differential equation. It is d5y by dx5 plus dy dx equal to y square. My differential equation is d5y dx5 plus dy dx equal to y square, and I am interested in knowing what is the order and degree of this differential equation. So Rohit, I'll ask Rohit, what is the order and what is the degree of this differential equation? Yes, Rohit.
Order is 5 and degree is 1.
Okay, so here comes the answer. So Let's discuss the order first. d5y dx5 is the highest order derivative occurring in the equation. So the order must be 5. Now, look for any radical sign, if any, in the differential equation. And you observe that there are no radical signs. All derivative terms are free of radical signs. So I look at d5y dx5, which is the highest order derivative term, and I see that it occurs only once with a power of 1. So my degree is 1. So I say this differential equation is of order 5 and of degree 1. Take another one. Suppose my differential equation is d3x dt3 plus d2x dt2 plus dx dt whole square is equal to, let's say, e cube. Now I'll ask Iqbal, what will be the order and the degree of this particular differential equation? Yes, Iqbal?
Sir, the order is 3 and degree is 1.
So I see that you're getting my point. The order will be 3, correct, because d3x dt3, remember students, in this particular differential equation, the dependent variable is t, the independent variable is x. Variables don't matter, they can have different names under different circumstances. In this case, the dependent variable is t instead of y. Coming back to the order, d3x dt3 students is the highest order derivative term occurring in this equation. So I say that order is 3. Now for the degree, you have d3x dt3, you have d2x dt2, you have dx dt square, but the power has to be seen only for the highest order derivative term. Remember students, even if dx dt has the power 2, it won't be of any use to us. We'll just look at the power of d3x dt3, which is 1. d3x dt3 is the highest order derivative term occurring. It is occurring only once and it is occurring with a power 1. So I say the degree of this differential equation is also 1. We'll take up 2-3 more examples, students. Suppose I have a differential equation which goes like x square d2y dx2 cube plus dy dx raised to 4 plus y power 4 equals 0. I see that d2y dx2 is the highest order derivative term, so my order is 2. Look for the degree, there are no radical signs. dy dx occurs with power 4, but d2y dx2 occurs with power 3, so I say the degree is 3. The given differential equation is of order 2 and degree 3. Take one more. Suppose xy square plus x times dx plus y minus x square y dy equal to 0. Sometimes students, what will happen is the differential equation given to you will not be in terms of dy dx, d2y dx2 or d3y dx3. dx and dy will be treated as quantities and dy by dx will actually be taken as a quantity dy divided by a quantity dx. So in these cases, what you do is you create terms of dy dx and d2y dx2 and then go for degree and order of the differential equation. So you have dy dx is equal to, take this term to the other side, divide by dx, and you have xy square plus x over x square y minus y. Once you got the differential equation in the standard form wherein the derivative terms are like dy dx, d2y dx2 and so on, you can easily read the order and the degree of differential equation. So here we have order 1 because dy dx is the highest order derivative term occurring, and degree 1 because it is occurring with power 1. So here we have a differential equation whose order is 1, whose degree is 1. We'll take up another example, students. Suppose my differential equation is cube root of 2 plus d2y dx2 is equal to square root of 5 plus d3y dx3 whole to the power 4. Now students, you have a cube root on one side, you have a square root on the other side, and both terms have radical sign, or rather derivative terms underneath them. So you need to remove these radical signs before you find out the degree of the differential equation. The order is very clear. The order of the differential equation is 3. It's only for the degree that you need to remove the radical signs both from left hand side and from the right hand side. So I raise both sides to 6 and I get 2 plus d2y dx2 whole square is equal to 5 plus d3y dx3 whole to the power 4 whole raised to 3. Square root raised to power 6 will make it cube, and cube root raised to power 6 students will make it square. Now when you expand 5 plus d3y dx3 power 4 whole cube, you will get different powers of d3y dx3, and I am interested in the highest power of this. So highest power will be power 4 whole to the power 3, that is power 12. So I say the order of this differential equation is 3 and the degree will be 4 into 3, that is 12. So students, in this module we looked at the definition of a differential equation, what is the order of a differential equation, what is the degree of a differential equation, and when you are reading the differential equation, or rather the degree of a differential equation, you must remove all the radical signs which are under the derivative terms. Whether the highest order derivative term or any other, all derivative terms must be made free of radical signs before you read the degree of the differential equation. In the next module, students, we'll look at the first part of the differential equation, which is called the formation of differential equation, in which, given a relation between y and x, we will see how we can frame a differential equation which will be the solution to that differential equation. Thank you. To summarize the module, students, an equation containing an independent variable, usually x, dependent variable, usually y, and at least one differential coefficient of dependent variable with respect to the independent variable is called a differential equation. The order of a differential equation is the order of the highest order derivative occurring in the equation, and the degree of a differential equation is the degree or the power of the highest order derivative when differential coefficients are made free from radical signs and fractions.